Yeah, hello guys. So in our last video we treated direct variations, and we said direct variations can be referred to as a situation whereby a variable increases with another or decreases with another. But yet this would be the total reverse, the reverse case for what we talked about in direct variation. So here we have it as the direct opposite of a direct variation, in the sense that as one quantity increases, the other tends to decrease, and vice versa. So what this means is that if a quantity measures 40 kg and another measures 30 kg, when that same quantity the first quantity measures 50 kg, the second quantity will decrease, not increase, as the first one has increased. So this means when somebody is gaining, the other one is losing. When someone is gaining, the other one is losing. They are both not gaining at the same time. It's either one is gaining while the other one is losing, or the first one is losing while another one is gaining. So that is what this is all about. And how do we represent this? This can be represented mathematically by this: x varies inversely as y. In our direct variation, it was just x varies directly as y. There was no reciprocal form. But here we have the inverse. Inverse of y is 1 over y. It is also the same thing as the reciprocal of y. So here, this is how we represent our distance. So how do we now involve our k? Look at how it is now. So now have x equals k into brackets 1 over y. And here we have it as x equals k over y. So this is our representation for an inverse variation. So all inverse variations have this kind of sample, this kind of approach. So this is our way to solve it. Unlike the direct variation, which was x equals ky, here we have it as x equals k over y. So let's just try out some examples. Okay, so all these, if you are to find your k formula, your constant of proportionality, then to be so straightforward, you would have it as k equals x times y, and then k equals xy. So let's see some examples under inverse variations. So the first example we have here is if x varies inversely as y, when x equals 9, y equals 3, find the formula connecting them. There is not much difference between this and direct variation in terms of solving. In variation, what you need is your correct formula. So here we have a formula to use. This is talking about inverse variation. So you note the word inverse, and you note the kind of formula to use. So we have it here as x varies inversely as 1 over y. Or x varies inversely as y, rather, not 1 over y, as y. So it becomes x equals k over y. And then you put in your variables, you chip in your values. X equals 9, y equals 3. So have 9 equals k over 3. And so we have it here. So if we were to make our k this W formula, we'll have to cross multiply. So by cross multiplying, we have k equals 9 times 3. And by my calculator here, it gives me 27. So it is as easy as that. So, but then we have to find our formula connecting them. So how do we get our formula connecting them? We only need to put in our k value. So our k value now becomes what? X equals 27 over y. And this is the answer they're asking for. So let's try another example. Okay, we have it here. The square of x varies inversely as a cube of y. When x equals 2, y equals 3. Find y when x equals 6. Okay, so here it said the square of x. What does it mean to say the square of x? The square of x means x multiplied by itself, that's x squared. It is the x squared that is varying inversely as a cube of y. Cube of y means what? Y multiplied by itself twice. That's when you multiply y by y and by y again, we have y cubed. So here it is the square of x as a variable on its own that is varying inversely as y cubed as a variable on its own too. So we have it here as we have square of x equals x squared. We also have the cube of y equals y cubed. So here we have a variable. This is our formula to use. So x squared varies inversely as y cubed. And then we put in our k value. X squared equals k into brackets y 1 over y cubed. So keeping in our variables or values, we have x equals 2, y equals 3. So this one gives me 2 squared equals k over 3 cubed. So while expanding, 2 squared is 2 times 2 equal to k over 3 cubed, which is 3 times 3 times 3. So 2 times 2 is 4. 4 equals k over 3 cubed should give you 27. As in 3 times 3, 9. 9 times 3, 27. So half 4 equals k over 27 here. So if I cross multiply, I should have k equals 27 times 4. And by present calculator, we have k as 108. So k equals 108. So the formula connecting them now becomes x squared equals 108 over y cubed. So now we are asked to find y when x equals 6. Now this is very straightforward. We've known what our k is. We've been given our x as 6. Find y. So we just put in our values. We have 6 squared equals 108 over y cubed. Let's make our y the surrogate formula, but before then 6 squared is 6 times 6, which is 36. So we have it as 36 equals 108 over y cubed. So by making y the surrogate formula, we have y cubed equals 108 over 36. So if you press that into a calculator, you should have 3. So y cubed will give us 3. So how do I eliminate the cube here? In order to eliminate my cube, I have to find the cube root of both sides. So by finding the cube root of both sides, I can easily eliminate my cube. So as it says here, to eliminate the cube, we'll find the cube root of both sides. So this is how I find my cube roots. It's affected both sides, both the left hand side and the right hand side. I had to use 1 over 3. I mean the power of 1 over 3. So, and here I should have y raised to power 3 over 3, which should give me y raised to power 1. And this other side, 3 raised to power 1 over 3. That should just be like that. So we have it as y equals 3 raised to power 1 over 3 as our y. So this is the answer they're asking for. So we are done here. Let's try another example. So here it says a varies inversely as the difference between x and y. When a equals 10, x equals 7, y equals 4. Find the relationship between them. Okay? So here we need to get what our formula is first. So find the formula connecting them. So what connects them? A varies inversely as. So you note the word inverse. Inversely is 1 over. So a, and then the difference between x and y is x minus y. So that's the difference. So let's just use x minus y. And then we have it as this. A varies inversely as x minus y, which means as a increases, x minus y has to decrease, or as a decreases, x minus y has to increase. So that's what it all means. And then we have our a to be 10. Okay, let's put in our k value. We have this. So okay, let's cross multiply. Gives me k equals a into bracket x minus y. So here I can just easily chip in my values and get my a directly without having to do any further simplification. So a equals 10, x equals 7, y equals 4. So k equals 10 into bracket 7 minus 4. So 7 minus 4 is 3. So that will give me 10 into bracket 3. 10 into bracket 3 is 10 times 3. So that gives me 30. So my k is 30. So my formula now becomes a equals, okay, by this k over x minus y. Now that k is 30, we have a equals 30 over x minus y, which is the relationship between them. Okay, so that's about that. Let's move on to the next example we have here. So here in this example, this talks about logarithm. So we have it as log 3 base x varies inversely as log 2 base y. When x equals 3, y equals 4, find the relationship between them. So here we only need to find the formula connecting them. So we need to find what our k is. How do we go about this? Okay, so this is not just mere variation. This is a combination of variation and logarithm. So we would have to be using some log rules here. So here we have it as this, varies inversely as this. Okay, this is very much straightforward. And then bringing your k value, we have it as this as well. And then it says when x is 3, y equals 4. So now putting in x as 3, we have log 3 base 3, right? Yeah, log 3 base 3 equals k over log 2 base 4. Okay, now in logarithm, log a base a is always equal to 1. If the base and the value of a log are the same thing, your answer is 1, tends to 1. So it says here, it's 1, so log a base a is 1. So note that rule. So, and that makes log 3 base 3 1. So now it has been simplified. And also log a squared base a can be written as 2 log a base a. You can just carry over the 2 to the left hand side. You carry to the left hand side of the log, to the back of the log, to have log a base a, and log a base a is 1. So that will be 2 times 1, which is equal to 2. So if I have something like log 4 base 2, I can rewrite it as log 2 squared base 2, because 2 squared is 4. And then the square on top, I can move it to my left hand side and have it as 2 log 2 base 2. And 2 log 2 base 2 is what? 2 times 1, because log 2 base 2 is 1. So I have it here. So my log 3 base 3 has become 1. So that gives me k equals 1 times log 2 base 4. But how do we solve log 2 base 4? This is not log 4 base 2. This is another rule. Log b base a is equal to 1 over log a base b. So this is a very simple rule to note in logarithm. If we have something like log 2 base 4, it is also the same thing as writing 1 over log 4 base 2. So here I can easily convert this log 2 base 4 into log 4 base 2 by finding the reciprocal, the inverse. So I have it here as k equals 1 times 1 over log 4 base 2, and not log 2 base 4 anymore, because I've put in my 1 over. And now I can easily solve this. I have k equals 1 over log 2 squared base 2, and then my 2 will move to the left hand side as I have it here. Now give me 1 over 2 log 2 base 2. Log 2 base 2 is 1, so that should give me k equals 1 over 2 times 1, and then we have k equals 1 over 2, as easy as that. So we have to find the formula connecting them. So we have it as this. This is our initial formula we used. So now that we've found our k, just put in your k. We have it as log 3 base x equals 1 over 2 over log 2 base y. So my 2 goes down. It gives me log 3 base x equals 1 over 2 log 2 base y. It could easily become log 3 base x equals 1 over log 4 base y, but we're not going into that. This is just a formula connecting them, and then we are done. with these. So you can do this yourself from question 4. This last example, find x when y equals 16. Try that yourself. Our answer is root 3. So when you work it out, you should get root 3. So thank you very much, and then tune in for the next video. The next video will be treating joint variations. And don't forget to click